Hi, I'm Nick Anderson, Product Manager for Creative.space, and in this video I'm going to show you how to manage a Creative.space node with the system page, even if you don't have any background in IT. What we've done with the Creative.space software is streamline the entire process of managing storage with an intuitive user interface. Traditionally, the things I'm going to show you would require some specialized knowledge and the use of a command line. What do I mean by command line? I mean literally typing in commands by hand. Not only that, some tasks require executing multiple commands and cross-referencing information, not user-friendly by any stretch of the imagination. With that, let's dive into the user interface. The first thing you will notice is that we need to log in. This is very important. All access to Creative.space nodes is authenticated against a built-in LDAP server. You might be wondering, what is an LDAP server? Well, it stands for Lightweight Directory Access Protocol. LDAP is the underlying framework that user management systems like Active Directory are built on. Basically, it's what authenticates usernames and passwords to securely access a system, allowing you to control who can read and write based on users and groups. While other vendors support LDAP, Creative.space is the only platform with a fully integrated LDAP server. Throughout this video, you will see how this user management system is integrated into the overall platform to provide deep control and visibility without requiring extra effort on your part. Let's go ahead and log in. This account has been assigned the system admin role, so I'm taken to the system page first. In the top right, you can see the connected users module. Let's check it out. Here you can see all of the users connected to your node, how they're connecting, and what they're accessing. All pop-ups are managed as cards, which you can move around, minimize, and carry with you throughout the interface. Pretty cool, right? Now, how does the storage actually work? On a very basic level, you put drives into the server, those drives are added to a pool, spaces are created in the pool, and then user and group permissions are written to spaces and the files and folders in them to control access. Here, you can easily view all of the information about your pool and how capacity is distributed. Zpool shows you the raw capacity of the pool. This capacity is then reduced by raiding the drives. Here we show you both the capacity taken by the raid and how much is left usable afterwards. When you raid, you replicate your data across drives so that data can be recovered if one of the drives fails. This is something we discuss with you and configure before shipping your system, so no need to worry about it now. Moving on, you can see how much capacity you are actively using, how much is being used by snapshots, which I'll cover later, and how much is still available. When you use over 75% of your capacity, available capacity will turn yellow. If you pass 85%, it will turn red. It's best practice to never use more than 80% of your capacity, since performance drops as data is written to the outer edges of your hard drives. Clicking on any of these numbers toggles between terabytes, tebibytes, and percentage. If you ever get confused as to why the capacity your operating system shows seems to be less than what you thought you bought, that's because it's using tebibytes and not terabytes. What's the difference? Terabytes are measured by 1000, and tebibytes are measured by 1024. Now, below the pool info, we can see all of the spaces in the pool. Spaces are virtual storage volumes where users can store and access their data. Still confused? Think of a space like a normal hard drive, except multiple users can connect at the same time and collaborate. Let me show you. I'll go ahead and create a new space. I'll give it a name, and share it with other users by adding a group. Now, I've been taken to the Spaces page, but I'll go back to the System page to show you a few more things. Let's go into the settings for the space we just created. Here, you can set a quota or a reservation for the space. By default, all spaces share the full capacity and performance of the pool. Setting a quota puts a limit on how much capacity a space can fill up. A reservation, on the other hand, limits how much capacity other spaces can use, in effect reserving capacity for the space you set it on, protecting it from being lost. You can use quotas and reservations to regulate capacity usage to prevent getting stuck in a position where you're out of space but don't have time to clear things off. You have the option whether or not to include snapshots in your quotas and reservations. I'll go over snapshots in a sec, but before that, let's finish going through this page. Expand the options and scroll down to the bottom to find the delete button. Unless you have in-depth knowledge of the ZFS file system, you should ignore the rest of these settings. Okay, let's go into snapshots. A snapshot is a read-only backup of a space at a given point in time. Taking a snapshot is instantaneous, and it won't take up any additional space until the files are altered or removed from the space, at which point the snapshot will grow. Snapshots provide an additional layer of protection for your data, allowing you to pull back files that are accidentally deleted or changed. Now, snapshots are not a real backup, they just prevent data from being deleted. Nothing is actually copied or replicated, so we still recommend having an additional backup solution. In the snapshot card, you can take snapshots now, in the future, or even on a scheduled interval. Snapshots are part of the ZFS file system, but we've enhanced the feature with scheduling, browsing, and expiration dates. When you set a snapshot to expire, it will automatically be deleted at the set date and time. This makes it easy to manage snapshots, since you can set up a schedule that makes sense to you, and the old snapshots will automatically phase out. You can see your scheduled snapshots in the Scheduled Tasks card. Here, you can delete them if you like. Below this is the Networks module. Here you can see and configure all the network interface ports on your node. In order for a workstation to talk to the storage, both systems need to be in the same subnet. See this number that's divided by decimal points? That's an IP address. It has 4 sections. The subnet is defined by the first 3 sections. The last section, then, needs to be unique and below 255 to prevent overlaps. Let's go into the network settings by clicking the gear icon. Here, we can see the basic info for each of our ports. The port name, whether it is configured, what the current IP address is, the MTU, whether it's set for DHCP, and the type of connection, whether it's 1, 10, 25, 40, or 100 gigabit Ethernet. Don't worry if you don't know what half of that meant. I'll go into that in a sec. Let's click on one of the ports. By default, ports will use the name the internal system uses. However, you could set your own custom nickname that is easier to remember. The MTU setting controls the size of packets that will be sent over this connection. It is very important this setting matches on both sides. The most common cause of performance issues is mismatching MTUs. For 1 gigabit Ethernet connections, use 1500. For faster connections, use 9000. Now, this connection is set for DHCP. This stands for Dynamic Host Configuration Protocol. This protocol automatically negotiates IP addresses between the server and clients. We only recommend using this for connecting to the web app and not for mounting storage. If you turn off the DHCP, you can manually configure a static IP address. If you need help with networking, just reach out to our support. We are almost done. Just 2 more modules to look at. Let's scroll down to the bottom of the page. On the left, you can see system information where, you guessed it, you can see all the system information, such as the system's inventory, time zone, live system time, how long the system's been on, the software versions, and the broadcast name. The broadcast name is a custom address that you can use to connect to the node instead of an IP address. Each user may connect using different IP addresses, but they can all use the same broadcast name. This makes it really easy to access the web app and makes it possible to share links. We can edit the broadcast name by clicking the gear icon in the top right of this module. Whatever you type in here will be the address with a .local extension. I've set mine to rogue1, so the broadcast name is rogue1.local. In this card, you can also set your time zone and your network time protocol server. You can leave the NTP server as global unless you have your own server that you want to use. The other thing you can do from the System Information module is reboot and shut down your node. Finally, we've got the Services module. This is where you can view and edit the various services we've integrated into the node. First is the Samba service. This is the protocol used to mount spaces to your operating system. If you run into issues connecting, you can restart it here. Next is our support service. This is a secure VPN connection that allows our support team to proactively manage your system. If there are issues, you can restart it. Otherwise, you can start, stop, enable, or disable it to control our access to the system. The level of support we can provide depends on this connection. That being said, we're happy to adapt to your unique security requirements. Next, we've integrated a file transfer protocol server. FTP is supported by various free and paid applications and is an efficient way to send and receive data. Another unique feature to creative.space is that we've integrated the LDAP server into the FTP server so that folder and file access is controlled by the same permissions you already have set up. Here, you can start, stop, enable, and disable the server as you like. We recommend only using the FTP over a VPN or within your local network, since it isn't 100% secure. Finally, you can see our API in detail. Each API task shows its status, token, date and time, who triggered it, what it affects, what task it is, and where it was triggered from. When you click on a task, you can see the entire process. Our secure API uses a lockstep system to authenticate all tasks before executing them. As you can see, the system page gives you a lot of control over your system without getting too technical. Thanks for watching this video. If you have any questions, you can reach me at niktaanderson@digitalglue.com.